Hello students, in this video we are going to learn about formation and the working of PN junction diode. A single crystal of silicon or germanium cannot be converted into a diode directly. They need to be doped with acceptor as well as the donor impurities on both sides of the crystal. Therefore, here the P-type semiconductor is doped on one side and the N-type semiconductor is doped on the other side of the crystal. That forms a diode. And these two, P and N, will be taken as a two terminals for this diode. Here, because of the doping process, the concentration of the majority charge carriers like electrons will be more in N region and holes will be more in P region, having these holes as the minority charge carriers here and electrons as a minority charge carriers on the P side. When there is no external voltage, we have to discuss here the two processes involved in the PN junction diode. Number one is the diffusion process. Number two is the drift process. During diffusion, what happens when P and N are connected? Here there is a diffusion of electrons from the N side towards P side, and also these holes, they also capture these electrons. During this diffusion process, there is a current generated and that current is known as a diffusion current. It is due to the diffusion of majority charge carriers across the junction that is shown from P terminal towards N terminal. And during this diffusion process, these electrons, they leave behind the positive ions, and also here these holes, they leave behind the negative ions and they get accumulated in the small vicinity. And because of this accumulation, there is a depletion region formed, and this depletion region will have the immobile ions left, and also it is depleted of free charge carriers. So these free charge carriers are not allowed to diffuse across this junction. Therefore, this depletion region will prevent the diffusion of majority charge carriers, and also they develop a potential, and this potential is called as the barrier potential. And this barrier potential is shown here. It behaves as a false battery also, and this current which is developed is known as the drift current, and that current will be from N towards P, from N region towards P region. You can see here positive ions and negative ions. Because of this, there is a flow of current that is called a drift current. You can see here this is a depletion layer shown in between the two P and N regions, and this is a direction of electron diffusion. This is a direction of hole diffusion. And this barrier potential for silicon, it is 0.7 electron volt, and for germanium it is 0.3 electron volt. And during this depletion process, here there is no flow of majority charge carriers. In order to enable this majority charge carriers to flow across this junction and also to conduct electricity, here this PN junction diode needs to be biased. That means the external supply is to be given. That technique is called biasing of PN junction diode. And this biasing of PN junction diode involves two processes. One is a forward biasing and another one is reverse biasing of PN junction diode. Here is the symbol of PN junction diode, and this is the anode terminal, the triangle, and the line which is drawn across this is the cathode, and this is a circuit symbol of PN junction diode which will be used in all circuits, electronic circuits. Here is a working of a PN junction diode. You can look at this diagram. Here in the forward biasing as well as in the reverse biasing, the diagrams are shown. This is the actual circuit diagram shown on both sides. And this is a PN junction. P side is connected to the positive and N side is connected to the negative. And this is a forward biasing when the terminals are correctly connected with the proper polarities. And when we look at this reverse biasing, the P side is connected to the negative terminal of the battery and the N side is connected to the positive terminal of the battery. That is, the polarities are just reversed and hence it is called as reverse biasing of PN junction diode. During this forward biasing, you can see here this is the V, that is applied voltage which is passing through this direction from P to N junction. As we have discussed earlier, there is also the barrier potential which is developed, that is in the opposite direction, that is in the direction from N to P, and there is a series resistor which is also connected, and in the similar way you can also cross check with this diagram, and the current is measured by the ammeter. There is a milliammeter which is connected. During this process, the applied voltage V, it opposes the barrier voltage VB because they are in the opposite direction. Due to this, here we find the result like the VB, it gets reduced by the amount, where VB is a barrier potential, it decreases by the amount when you say due to the applied voltage. So by this amount it decreases. Because of that, the majority charge carriers begin to flow across the junction. Across this junction, that is, the holes will move towards the N and electrons will move towards the P side. And also the depletion region decreases, you can see, because of the flow of the majority charge carriers, there is a conduction possible and the depletion layer starts decreasing. It becomes very thin. That is, the effective resistance across the junction, it decreases. That also you have to remember, because of the conduction, that shows the effective resistance also decreases, which causes more forward current to flow. The current which is measured here in the forward, it is measured in the milliampere where the milliammeter is connected. Therefore, when the applied voltage, when we discuss in this way, the applied voltage increases, what happens in the forward biasing? Because of the resistance decreases, the current also, the forward current we are writing as IF, it also increases. Whenever applied voltage increases in this battery, and we can find the forward current also increases, and that is drawn in the graph. Here is a voltage taken and here is a current which is measured in milliampere, and you can find from this. There is a cut in voltage because after a certain voltage there is the improvement. There is a flow of current in the positive way. And you can also see in the similar way the reverse biasing of PN junction diode. That is, the P side is connected to the negative polarity and the N side is connected to the positive polarity. Here you can see the applied voltage, that is from the positive towards negative, it is in the direction applied voltage, and we all know that the potential barrier, that is a voltage developed by this depletion region, and that is also from N to P. Therefore V and VB, they are in the same direction. Therefore VB increases in this way because it is now, here we have discussed it decreases by some amount, but here the VB increases. Why? Because it is in the same direction of the applied voltage. You can also see the majority charge carriers move away from the junction, that is increasing the width of depletion region. Because of this, the barrier is in the same direction. The majority charge carriers, the holes will be pushed towards this side and the electrons will be pushed towards in the direction. Okay, therefore it has the width of depletion region will be more. It increases and hence it behaves as an insulator. Therefore the R, the resistance of this, the effective resistance, what happens here, it also increases and hence the current in the reverse bias, it decreases or approximately it goes to 0. There won't be any current flow because the majority charge carriers are pushed away from the junction. They do not diffuse across the junction and hence that results in the 0 current. But still we can see there is a less current flow. That current is called as the leakage current. Otherwise it can also be called as the reverse current. It is due to the minority charge carriers which are always present in each side, where P side there is always electrons as a minority charge carriers, and in N side there is always some holes which are left, and these holes and electrons, the minority charge carriers, they start diffusing. The electric field which is set up that pushes these minority charge carriers, and hence there is leakage current or reverse current is always present, but the amount of current is very less, which is measured in microampere. You can see here, there is a microammeter which is connected, which measures such a small flow of current. And here is a graph which is drawn between the microampere current as well as the voltage. And there is less flow of current, but after reaching certain voltage called breakdown voltage, which breaks the potential barrier by increasing this current, the reverse current, we can also break this potential barrier. At this we say it is a breakdown voltage, and hence there is a flow of current afterwards. A diffusion of charge carriers will begin. Therefore, we discussed here the working of PN junction diode and also its formation. I hope you understood this concept very well. Thank you for watching.